สวัสดีค่ะ Good afternoon, Dr. Ray.
Good afternoon, ma'am. Good afternoon.
How are you?
Fine, fine. Very fine.
Thank
So
you
nice
very
of you.
much. Thank you very much for joining us today.
Okay.
And welcome everyone to CESRA Talk on soil quality and soil health indicator for hastening the monitoring of soil and Indian perspective. And my pleasure to introduce our distinguished guest today, Dr. Sanjay Kumar Ray. He is a former principal scientist and head of Eastern and Northeastern India at ICAR, National Bureau of Soil Survey and Land Use Planning India. And Dr. Ray holds both a PhD and master degree in agricultural chemistry and soil science from University of Calcutta. His expertise cover natural resources management, soil chemistry, soil fertilities, carbon sequestrations and modeling, climate change, and soil and water quality. And through his career, he has authored more than 140 peer-reviewed research papers, over 250 publications, including books, journals, and hold 3 patents. He has also lead and contribute to around 35 national research projects. Thank you very much. Dr. Sanjay, thank you for joining us today, and we are honored to have you with us. And I would like to hand over the floor to you for your presentations. And following the presentation, we will open the floor for the questions and discussions. If you are ready, the floor is yours.
Yeah. Can I share now? Can I share my slides?
Yes, please, please.
Yeah. Good afternoon to all of you. And I wish to profusely thank the CESRA team for giving me this opportunity to present in front of them. And make it smaller. Excuse me, just a minute. Yeah. I was just adjusting my photographs. Yeah. Yeah. Hi, Nopmani madam. I used to like thank Madam Nopmani Madam, especially particularly because he has actually
Thank
given me this opportunity to present.
you.
Thank you all so much, and let me start. So, soil quality and soil health indicators for hastening the monitoring of soils, an Indian perspective. That's what Madam had actually told me, that if this I can talk in this direction. And you all know the soil quality and soil health both are sometimes used interchangeably or spontaneously, but not so. Soil quality actually, it depends on the mostly the soil functions, or the most all those little so-called permanent parameters which do not change over a shorter period. Whereas soil health is a very dynamic property, and that's which changes within 3 to 4 years, 5 years, depending on the management, on the inputs, and the type of land use and land cover you use. So these two perspectives are there. I shall here discuss soil quality. I'll little go into the basics also. I was thinking maybe some students are there, so I'll go into the basics how soil quality is being done, only for a few, because it's a huge database, but so we can't do it in within 45 minutes. So I'd prefer to take some few only, I mean, few database for explaining. Also soil health similarly. And You all know that the increasing erosion, soil loss of soil organic matter, reduction in fertility and productivity, heavy metal contamination, degradation of air and water quality have actually provoked interest in the concept of soil quality and its assessment. Several definitions have been proposed, but the one which proposed by Duran Perkins, actually USDA, United States Department of Agriculture, soil quality is defined as the capacity of a soil to function within ecosystem and land, sustain biological activity also, and maintain environmental quality, as well as promote plant, animal, as well as human health. So as I told you, soil quality and soil health are not synonymous, but two distinct parameters. The former one is related to the soil function, but the latter is a finite, non-renewable, dynamic living resource. Soil quality and soil health are useful tools for monitoring. And so they are used in just that perspective, that they are very useful for monitoring of soils. And there's no single parameter that can quantify soil quality. So it's better qualified by a combination of properties, because there are huge data sets. You may have 50 to 55 parameters of soils, but you have to come down to few data only to actually represent soil quality or soil health. So in soil quality, it is difficult to quantify directly. We develop a minimum data sets through use of some statistical functions. Okay, this indicator means it infers a soil's ability to perform some basic functions. Okay, and to perform as good indicators, selected soil properties should be sensitive, easy to measure, well related to land management effect of environment and also environment transformations. Soil qualities indicators must be well correlated. Suppose we may have clay as well as sand and silt, all we may get, all the three, but when you intercorrelate between them, you may get maybe say clay as the most important one. So correlation among them may be good. So we should take those properties which are independent and cannot be correlated with any other property. So we cannot include in the MDS all sand, silt, and clay. We have to use if they are intercorrelated among themselves. So soil quality indicators must be well correlated with quantifiable functions, must respond to measurable way of external change, both natural as well as anthropogenic, and must be adaptable for use by individuals with large background skills. Means all types of people should be able to use it. So I had a person from geography, I had a person from arts. I taught them soil quality, and they learned it, and they are now doing all over India. So though that is then one, it should be a range of individuals should be different background should be able to operate it. Must be found in existing database that are accessible and value to soil quality assessment. It must be integrated into larger ecosystem scale. That's very important. Models, including socio-economic models. So if you see the Indo-Gangetic Plains is one of the largest plain in the world, maybe second or third ranking whole world, and it has an area of about 53 million hectares approximately, and it's in the northern part of India, and it covers 13% of the geographic area of India. It's a major feed producing region. It produces almost 50% of food grains for 40% of the population. The major crops of the region: rice, wheat, apart from pulses, oilseeds, cash crops, horticulture crops, and similar crops also. Nowadays, they also do horticulture crops like citrus and also cotton also in these areas. This was achieved due to the texture, high input technology, including modern technologies of soil and land management, expansion of irrigated areas, strengthening of market infrastructure, etc. The production is not uniform across the region because of spatial variation in the land resource characteristics. This also you may also find in Thailand also and other countries. All regions are not equally healthy or equally good to produce, to have a good productivity. However, presently the yield of crops have stagnated due to high degree of physical, chemical, and water-induced degradation, number one. Number 2, nutrient imbalance and inefficiency. Number 3, depleting groundwater level. Number 4, pollution of heavy metals in soils. Number 5 is pollution of groundwater by nitrogen, phosphorus, etc. And that's really a very, very intriguing for us that this groundwater is also being polluted, and work is being done in this regard to mitigate those pollution effects. And then now we have the black soils region. You know, the whole, you can see the map. We have the black soils region, which runs into not only the peninsular area, but also to some other areas which are not black at all. So it has, it depends on where the position of in the landscape. Not irrespective of this area, it also has in Jammu and Kashmir. We also have Himachal Pradesh, Punjab. We also have in Assam. In the eastern regions also, we have eastern states also, northeastern states also, we have the black soil regions. So black soil regions are represented by actually string swell soils, which are called vertisols by US taxonomy, indicating we have to have cracks and a coal value of 0.06, more than 0.606. Okay, and these are also called vertisols in the World Reference Base for Soil Resources, which is a union of three, organizations: ISRIC, International Union of Soil Sciences, and FAO. So all three together have made this WRBSR, and according to them, these cells are called vertisols. The BSR extends mainly in peninsular India, parts of IGP, and associated with red and black soils. It is also associated in red soils also. Beside red soils also, you can find these in black soils also. And in some parts of non-conventional areas, the deposition on basins and valleys, mainly in basins and valleys, they get deposited. So you can compare with the agro-eco regions. We have done in agro-eco regions because to understand the climate is a very important factor in doing all this work. So on all these ecological regions, sub-regions, you have 52.1 million hectares on the IGP and 76.4 million hectares in the black soil region, covering all the states. You do not, because you may not understand, all this classification I have given under the US. We can also provide for the WRBSR also for your help. We can do that also. And the climatic variation in rainfall, temperature, AESR, variation potentially about aspiration. And we have data available for profile data, morphological, physical, chemical, as well as biological. So you can see so many, we say data available hotspots. Hotspots mean the benchmark spots. So you have around, say, 30 benchmark spots in IGP and around 20, 25, 26 around in the black soils region. These hotspots are actually monitoring spots. We cannot monitor the whole of the region because it's a huge area. You can see this huge area. 52 million hectares and 76 million hectares is a huge area. So we have done also from hotspots, and we can do all sorts of studies in these hotspots. So we have almost 53 to 55 data set for each hotspot area, including the biological, okay, morphological, physical, chemical, and biological. Although morphological data is not being directly used in the soil quality, but we are using it, giving it some scores, and also using it in soil quality assessment. So that very tedious database cannot be drawn. We are trying to correlate the morphological data with physical and chemical and biological data to actually facilitate easy workability of developing of the data sets. And for the extended data, I call the larger type of data. We have around 400 in each of these areas, 400 spots. And for that, we have around 25 to 26 data sets. You can see all depth, horizon, designation, color, all these inconsistent spots, including the particle size, water retention in 5 suction levels, okay? 33 kPa, 100, 300, 500, 1000, and then 1500 kPa. And bulk density, coal, saturated hydrogen conductivity, organic carbon, calcium carbonate. Calcium carbonate is we call it soil inorganic carbon. And we say soil organic carbon as a soil organic carbon SOC. and calcium carbonate as SiC, soil inorganic carbon. Okay, because most of the areas which I am discussing now, the major part is in the semi-arid semi-arid tropics. So you will find that a lot of accumulation of calcium carbonate in these areas, other than the high rainfall zones where we don't have calcium carbonate, and that has a very much impact on the soil quality. And we have pH, EC, extractive basis, and CEC, ECP, exchangeable calcium carbonate, exchangeable magnesium carbonate, exchangeable sodium percentage. And now see the climatic data. I just give you to have you an idea about climatic data. I put this, and then the variation in rainfall. Previous one was the temperature, and now this is the rainfall, and now this is the potential evapotranspiration. You can see in semi-arid tropics, almost the transpiration is almost equal to the rainfall, sometimes more than the rainfall. So we have a loss of moisture during that, plus you have a negative moisture in that region, and that affects plant growth also. And the clay percentage varies in such a way as a very high clay in the black soil regions, and then compared to the IGP. And then you have the soil organic carbon. It's of course also higher in the black soil region. The soil inorganic carbon, actually it's not much in the BSR, though there are in some areas. But IGP, some areas, a lot of deposition of calcium carbonates in the area. And you have the bulk density. There's some problem in the bulk density of BSR. I have to correct it, I think. Some graphs are not right. Okay. And now you have, this is the cropping pattern. Cotton, wheat, mustard, in the various AESRs, in the various agroecological means agroclimatic regions or agroecological regions, whatever you say, along the climatic regions, these are the various major cropping patterns. These are major ones, other crops also there. And in the black soil region also, we have this cotton, this cropping pattern, and this mostly based on cotton. Cotton is the major crop in this area. And now you can see how we developed this soil base, and you can see that we have hot spots and extended data. Both we have. Then we have morphological, physical, chemical data for both of these. And from that, we have developed drainage maps, revision of AESRs also we are doing, the sub-regions. With more refining, more data refining, we can define much better. So we also have developed PTFs for some data sets. For inaccessible areas, or we develop the data from PTFs, and soil and land quality parameters also we developed from in this. And GEOSYS is geographic soil information system, and SOTER is soil and terrain database. This we have developed through ISRIC, Netherlands. Yield gap analysis, land evaluation, and here you have soil and land quality indices by PCA method or other methods which I come across. And GEOSYS, or the geographic soil information system of the IGP and the BSR. And now the flow chart for the soil quality parameters. The soil parameters, we have principal component analysis. We also have expert opinion. I'll tell you what I think you must have known about expert opinion. See, expert may be anybody, say, like Madam Nopmane, or who really is an expert in Thailand and other areas. So she can say that, no, this area, pH is not a problem, but soil organic carbon is a much better parameter. So we can go through with her expert opinion, and we can do along with the expert opinion. Sometimes we get better results. I'll tell you later. We get better results with expert opinion because it gives an idea from experts who have been working in this area for a long time. So we develop minimum data sets, and from there we develop soil quality indexes. That's what 3 indexing methods we employed: additive, weightage, and expert opinion. So I will here discuss only additive because the huge data sets. Others you can also know, we can have a question also, and expert opinion also will be discussed in brief. Yeah. So here the hotspots and extent data for the BSR and the IGP. And here the hotspots for extended data for the, again for BSR and IGP for the extended data, and previous was the hotspot. And the hotspots, this is mainly in the black soil regions we have, you can see it's mainly cotton here. And we have data, so much types of data. You can see we have developed soil quality and soil health for 0 to 15 centimeters, 15 to 150, 0 to 30, 30 to 100, 0 to 50, 50 to 100, then 100 to 150. So many levels of data we have here. I will discuss only for 1 or 2 depths maximum because time will be not sufficient to discuss anything. Others can be understood as such. And for extent data also, we have similar type of database developed. There's a huge database we have. And now you can see the PCA for the hotspots for the surface soils 0 to 15 centimeters, 15 centimeters, and it was, you can see the origin values. I'll tell you, I think if you don't know how to, I think most of you know how to get the weightages. What you can do is the cumulative variance. You can see PC1 24.781 divided by 83.358. That gives you the weightage for calculating the SQI. So multiplying with soil factor to get the SQI. Okay. And for the PC2, 40.761 minus 24.781 divided by 83.358. Okay. So this is what how we develop the weightages, and weightage should be maximum 1. It shouldn't be more than 1. And that weightage, if you multiply with the soil factor, you get the soil quality index. And here I have shown only the sum, absolute sum. So you can do the absolute sum here also. This method also you can do. So you can see I have got 6 PCs for the hotspots, which actually have almost 80%. It should be minimum 80 to 83, 82 to 85% minimum should be the value of the cumulative variance. Otherwise, if you have, you can have more PC. If it is not 83, more than 80, you can have more PCs also. So in black soil regions, you will find there are 8 PCs developed because we are not getting the cumulative variance. So the amount of variation in data will give you a very good PCA result. PCA result depends on the variation in the database. If the database are similar type, all similar pH only 5.4, 5.4, 5.4, 5.5, 5.5, then you don't have good PC results. Okay. So this what is saturated highly conductivity also. So you can see those bold ones are those which have been selected because these are the highest, you know, in each PCA. And we have made a sum of this. We have made a sum of this, and you can find that these are the summation of this, and this summation we use for calculating the, and these are all so many 53, almost 53 parameters we have used, you can see. And for the hotspots, MDS for hotspots, for the upper IGP also we have done. And so here we get fine clay, hydroconductivity, conductivity, organic carbon, saturation percent, and solution K. So these are, you get different things for different depths also. And you can see here 0 to 50 centimeters we get, these are actually soil series. In a series, we define a series which are uniform, a particular area, polygonal area which is uniform with respect to the the management and also the productivity of soils. So you can see we're using PCA and using expert opinion, we are getting almost similar. Both Sakit and Sakit we are getting both same. There will be slight variation in the lowest SQI, but the highest SQI we are almost getting similar ones. And this is the one for 15 centimeters for the highest and lowest for extended data now. And similarly for highest and lowest for the 15 to 150 centimeters data. I am giving in short, okay. because all those data will develop for all these depths, and these are the database which were developed. And now we come to the black soil region, which is almost 388 database. Now we have much more, about 780 database throughout IGP and about more than 1,000 database around the BSR. By this time, this database is way back in 2015. So now it's quite, by this time, we have much more database. So similarly, we have developed this, and for 50 centimeters, you can see here 15. Again, here 6 pieces, but in some other depths, we get also 7 pieces, 8 pieces also. Principal components for this. So you have shown here only the absolute sum. About almost 53 parameters were used. And BSR hotspots is 50 centimeters by absolute sum method. So here you can see 0 to 50 centimeters, when we calculate, we get 8 pieces. And these are the independent parameters which are ultimately found, ultimately obtained for developing the soil quality index. This is how we develop the soil quality index. And I have also, you can see RSQI, that is relative soil quality index. Means because it's a huge area, you can understand 76.4 million hectares is a huge area. And so within the black soil regions, the highest data is in Konheri. So that we take as 100. And based on that, we calculate the relative soil quality index to other areas also. Okay. And these are basically the hot spots or the benchmark spots. And this is also the for 50 to 100 centimeters. And you can see the SQI, RSQI for, again, for you get the Lala Chora Bidisha, Madhya Pradesh is the highest, and the lowest is in Gujarat, which is very almost arid area. Almost arid area in Gadha, Meshana, Gujarat is an arid area. So it's a very low SQI and RSQI. And you can see, find here that we have developed this 8 PCs, and these various depths, we have got various different in the MDS. The minimum data sets have changed here. Okay. So, but expert opinion also is different here. Expert opinion has given some database here. Okay. So, I've given here PC1, you can say clay, carbon, both are good. So one of these you can take, that's what. But the expert opinion has not taken carbon as the first one, as the most rated one, but the last rated one, because we don't have much carbon in our soils. These are semi-arid tropics, and so carbon is almost in average 0.5 in the 0.7 to 0.5 in the surface, and the subsurface is 0.2, 0.3, 0.1. So soil carbon almost came as almost the last but one PC. And so you can similarly, we have developed this, you can say PCA for these two, for as well as for PCA as well as expert opinion. And we get almost similar results. You can see Jajapur, the lowest one is matching with both expert PCA as well as expert opinion. And now same thing here for, as I showed earlier also, PCA expert opinion is both are same, but this little varied. But the SQI is almost very close together, 37 and 34. So we have actually correlated with the yield of crops also, but the correlation is not that encouraging because of the huge data sets. When you do it in the small area and with more intensive data sets, then you can get much better, which we also published in Basu et al. You can see we have got 0.6 or above 0.7, 0.8 also. So with minimum data, with more intensive data sets, you can get much better results because these are huge data sets. So we have got the correlation, very modest correlation, but. And now for the benefit of students, I think if students are interested, I also discussed the land quality index, which is also not a part of this, but I would like tell them how we develop the land quality index also. Same thing with soil information system, the IGP, PCA, then we develop MDS, we do SQI, and here we use the climatic data, rainfall, temperature, sunshine, humidity also, other data also we can use. We have rather used, I have not put here now. So you can have a range of data to develop CQI. How close can you go? How accurate can you go towards the development of LQI? And then we have done the AHP also. You used artificial hierarchical process using mathematical matrices. We have developed this SQI and LQI, CQI, and we have multiplied SQI with CQI to get the LQI, the land quality index. And that also is very good parameter for one to understand what is the quality of the land. And so that's what you can see. You can see here that the SQI and the LQI were developed, and you also developed the relative land quality index. And you can see Haldi, which is a molly soil. Molly soil is a very fertile soil. So you can see Haldi in Uttarakhand area of the lower, the very low foothills is the highest, having highest land quality rightly. And the Berpura in the almost semi-arid to arid area in the northern region, that's in Haryana, this Haryana state, having the lowest land quality index with a lot of problems, with a lot of sodicity also issues are there. So you can find that Berpura is the lowest land quality index. And this is very interesting. And I think the students can also, if they have not already done, they can do this. And the land quality index, we have put it in form of map also here. And if, for rice, for the rice crop, we have developed the land quality index. And you develop the land quality index for wheat also, wheat crop. And relative soil quality index of rice cropping and relative. And here now we are coming for biological parameters. One of the most important parameters, which really is very much interesting, because this is the one which really talking about the 3 to 5 years duration, which varies with small variation in the climate, in the land use, in the management, and so on and so forth. So we have studied the dehydration activity, and we are one of the most few who have developed, studied the dehydration activity along a profile, soil profile. So you can see the dehydration activity, it decreases along a profile. We have that then for two depths, 0 to 15 and 0 to 100 centimeters. You can see, I think Madam Nipone must be remembering ICAR-NBSS. So we have taken the ICAR-NBSS soil also, carceratipally it's called. So you can see it's having 3.67 of at this HM is high management. Under high management, so much of dehydration activity, and the low management we have a lower activity. And as the depth increases, you can see gradually the dehydration activity decreases. So we can, from this, we have also developed PCA and done PCA for all these health parameters also, including organic carbon, organic carbon, pH, and everything. And so I'll give a gist of all those to you. Dehydration activity declined with increase in internal depth. That's very clear. The maximum dehydration activity was found to be in the surface horizon, and very much clear also, and decreased with depth, almost similar, 1 and 2. Cropping systems and bioclimates significantly influences the DHA in soil. The average DHA in different bioclimates when increasing order. So subhumid, moist was highest in then semi-arid, then subhumid, and then arid. One discrepancy in subhumid, semi-arid dry, and subhumid dry, maybe due to the management factor, but otherwise it should be the otherwise down. And in different cropping systems, its legume system is higher than cereals and cotton than sugarcane. High management practices found to be significantly increased DHA compared to low management, whereas no significant difference was found in DHA between irrigated and rain-fed systems, because of the DHA is similar in both irrigated as well as the systems because of the maybe the management systems are similar. And now you have the soil microbial population. So microbial population is significantly positively influenced by clay, fine clay, catalysis capacity, and base saturation. These are the soil quality parameters. And soil microbial population is significantly positively influenced by water content, electrical conductivity, and soil organic carbon. These are the soil health parameters. Whereas bulk density, hydraulic conductivity, and pH, the soil health parameters, have a negative effect on soil microbial population. And calcium carbonate and exchangeable calcium magnesium percentage have also a negative effect on the soil microbial population. And as the soil quality parameters, these are soil quality parameters. The yellow ones are the soil quality parameters, and the light blue ones are the soil health parameters. An relation between soil microbial population and soil properties also, I'm just giving some gist here. The bacterial and fungal populations are strongly negatively correlated with soil depth. Maximum microbial population was in surface horizon, most obvious. In general, the bacterial population higher than actinomycetes and fungal populations in soil profiles of the IGP. And this was reflected in our soil quality and PCA analysis. Approximately 10% decrease in Shannon diversity index was observed, with increase in 30% of centimeter of depth. Okay, so depth also matters. Depth study of through the depth is very important, and that I will also tell you later. Non-significant difference between microbial population was noticed across management and land use systems. Subhumid moist bioclimate systems recorded higher microbial population than subhumid dry and semi-arid bioclimate systems. Legume-based cropping systems and higher microbial population than cereal-based, as also shown for DHA also, and that show higher health indicators. These showed higher legume-based shows higher health indicators compared to other cropping systems. So for monitoring of soils for agrotechnology transfer, you can see along a landscape, summit, mid-hill, foothill, upper Piedmont, lower Piedmont, flat plain, and sandbars, how the soils vary and how you can manage the soils, monitor the soils for transfer of agrotechnology. And that's very important through soil health and soil quality monitoring. This is what we have developed on agrotechnology transfer. Say if you have hills, you can go for forests. They're very common, but this may be followed for better management practices. For upland, tea, agroforestry, and plantation, old alluvium, plain paddy, mustard, potato, peas, and all those modern irrigation systems also. And also, I mean, the modern agricultural practices. Recent alluvial plain, paddy, mustard, potato, peas, vegetables with conservation tillage. Shallow water, winter paddy, summer paddy, depending on depth of water. And in deep waters, you can have paddy, and you have iri have a variety, very good variety. Along with that, you can use fishery and duckery also. And NDVI, the normalized difference vegetation index, also can be used very well without really using remote sensing and GIS. You can also use for monitoring soil quality and soil health. And this is how we've done it. You can see the methodology. Here, for soil quality and soil health monitoring, you can see very interesting thing which you have got. So SOC is a health indicator. Soil organic carbon, you can see it increases in the humid tropics and decreases in the arid regions. Whereas the soil, the SCD or the surface charge density, it also increases in the humid tropics. And the surface charge density is the charge which is held by the clay particles, and that's the very important for sequestration of organic carbon. The higher the SCD, the higher the sequestration of organic carbon, and that's what we wanted to show, and it helps in the monitoring of soil health and soil agrotechnology transfer, and that's what I meant to I put the slide for your interest. And this one also, you can use soil carbon modeling by Century Model, ROTC, or DNDC. So through this carbon modeling also, you can also monitor the soils and at various intervals of time, and also you can project the future soil quality and soil health parameters. You can project particularly soil organic carbon, and if soil organic carbon is projected is also foretailed, then we can have an approximate idea of other soil parameters also, and that's how use of modeling also helps us to monitor soil quality and soil health. And now I conclude. The soil quality parameters indicate that there's a marked difference in property between upper and lower IGP. Of the upper and lower IGP, obviously upper IGP is more arid, and the lower IGP is is gradually going towards the humid region. Minimum data sets obtained by PCA matched well with those from expert opinion and with few exceptions. So expert opinion, it matched with PCA, it matched well. Soil quality indices obtained gave a modest estimate of correlation with rice and wheat. Though with small database, we have got obtained much better correlation. SQI was higher in those soils which were well managed. Proper addition of organic as well as inorganic fertilizer along with irrigation, in addition to optimum inherent properties, help to maintain the soil quality index. Among the indexing methods, weighted index by both PCA and EEO, weighted index, that means the weight factor, not the additive one, but the weight factor used for soil quality index, and the that also, as well as that developed by PCA as well as the expert opinion, was highly correlated with crop yields. However, the soil quality index estimated by EO weighted index showed a better correlation with the yield of some major crops. So we have got much better correlation with expert opinion, and though it matters, so that means always computers and softwares are not much better, are not better, but Madam Nopmany can be a very good expert opinion, and she can say, she can be above the computers and experts. So that's what helps, that what really matters, that the senior experts can give their opinion to develop soil quality index. And it's interesting that the subsurface soils contribute to a large extent towards the soil quality. About 84% of the area, indicating the importance of subsurface petrological research for managing and monitoring soils. That's very important also. I think other than 0 to 15 centimeter surface soils, you should also monitor the subsurface soils for plantation, for horticulture crops and the like. The surface soils of the IGP are overstressed as shown by their low SQI values. SQI and RSQI for both the BSR as well as also indicated the contribution of both surface and subsurface soils towards soil quality, indicating that the BSR is less exploited and the present cropping and management systems are sustainable in this region. So the cotton-based cropping system in BSR is still sustainable in the black soil region. The land quality index calculated from SQI and CQI, soil quality index and climate quality index, is a viable option to operationalize the minimum data sets to interpret the quality of land. And lastly, studying the soil benchmark spots or the hot spots at regular intervals is a useful tool for hastening the monitoring of soil quality and soil health. Thank you very much for your patience and tolerating me for 45 minutes.
Thank you very much, Dr. Sanjay. Thank you for your insightful presentations, and thank you everyone. I would like to kick off our first question from Kun Nopmany Sawannang. I'm pretty sure you have many questions regarding on soil health.
Yes.
Thank you very much, Dr.
Yeah, ma'am, please.
Jelly. I was very impressed with the health data set of the Indian that have been studied on the soil quality index.
Yes.
I was thinking that if the soil quality index, because from your study, the soil quality index explains like approximately, I think it's quite good percentage of the variation in the crop yields. But if
Yes.
they have the like expand less than 50% of the variation in crop yield, for example, in the rice yields, what additional factor that might explain for the remaining variation, and could they be incorporated into your future version of the index?
Yeah, madam, actually that variation was due to the huge area and the yield data. Actually, normally what we should do is we should collect the yield data ourselves. But what we do, sometimes we have the secondary data collected from others. So that's the reason where, and farmers conceal some data. They don't try to tell that if they get 20 tons, they say I got 15 tons. So that may be one of the reasons why you have got the 0.45 and 0.42, but it's much higher. You can see Dr. Vasu, our colleague and student and colleague. If you see that paper in Geodharma, you can find a much better correlation. So if you do it in a small area, you can get much better correlation. It is not due to the soil quality factors which have come across. It is due to the yield data which may not be as accurate as collected.
Okay, thank you. I have another question concerning
Yes,
to
ma'am.
the validation.
Yes, ma'am.
What's the soil quality index have been validated using an independent data set or through the cross validation? And
Yeah, it's independent data.
and how confident that it
Yeah.
would predict soil condition at site not include in the original analysis?
Ma'am, I couldn't get the last part of yours.
Yeah, I mean that when you make the validation, do you use the independent data set or you use the
That's
cross
what I told also.
validation?
We have to use independent. As I initially told you that if you have sand, silt, and clay, all the three, and after doing the PCA, you get all the three, sand, silt, and clay. That doesn't mean all three are we have to become the minimum data sets, MDS. But we have to do intercorrelation between them, and then t-test or whatever it is, and then find out which is the best one. So we have to reject all which are dependent. So we have to take always independent parameters. Although PCS which were ultimately taken are independent parameters.
May I have the last question, and then I will give the other people to ask some question to you. I was wondering that after you have the soil quality index from your study side, from your data set, what is the next plan for your national plan? I mean, because if I understand all the data that you have present us now is a national project, no, not in the individual project. That's why you have collecting in very systematic way, like the depth, everything. So my question is that when you have the soil quality index that is not fit, what is the next national plan that your Indian think that would like to kick out of the activity?
Yeah, we actually have to gradually improve our data sets. So each person is doing in their own, say, a PhD student is doing some work somewhere. So actually, gradually we have to improve the data. The data has to always gradually improvised. Also, methodologies also may improve through this. Through evolution, you can get much better improvement in the database. So you can find ultimately this has to incorporate into the national policies. Okay, so lot of data. These are the major data sets. So gradual corrections have to be made wherever people start working in soil quality, and this has to be into the national grid. We also have a geo portal in my former institute, and the regular database are being defined in that geo portal. So you can find in the geo portal regular database are being defined. So and that has to be that is always used for many purposes, not only for agriculture but for environment, for forestry, for environment, forestry, and many other uses. That's what for research, for clay research, for many other most other forms of data. Even many geographers, many GIS experts, they use our data. So that data is in the national, portal, and that can be used by people.
Thank you so much.
Thank you, ma'am.
Thank you, ค่ะพี่นก we have questions through the chat box from Karen, the Philippines. She asked about the, aside from microbial population count and dehydrogenase activities, do you also examine the level of soil respirations as well? And in addition, have you looked at physical parameters as indicator of soil health, such as decrease in bulk density or enhancement of aggregate stabilities?
Yeah, we do bulk density and stabilities also, that we do. But because we are a national institute and we work for the whole country, and it's not possible for us to do the respiration or the small research works. Okay, for that we have another institute, Indian Institute of Soil Science in Bhopal. They are doing that. So it is their job to do the research on the respiration and other aspects. We can also do, some of our scientists can take up, but normally we desist from doing that because we are a national institute and we mainly provide the data for planning purpose at various levels, at national level, at state level, at district level, at block level, various levels. We provide the data for research. So I'm sorry I don't have those data as respiration, but you can certainly find those with the other institutes in India.
Thank you, Ka. Hope that answer your question, Karen. If anyone having any question, yes, please feel free to drop in the chat box, or you can ask directly to Dr. Sanjay. We have like few minutes to go. And if you don't have any question, may I ask you a question from myself? During your working period, do you have some study on soil management practice that influence on the soil health over time as well?
Yeah, we do that.
You probably did.
We have done a management practice, and we have done it through almost 40 years. Database, we have soil management. That's how we can do soil carbon modeling. If you don't have the data, and we have experimental data with some crops, basic crops, say soybean, cotton, rice, wheat, major crop sorghum, and we have database for the last 40 years, and how it has changed, the organic carbon, and that also is the database is available with us. Because without monitoring, without having a change in database, we cannot develop policies for the country.
Thank you, Ka. And probably this is the last question that from myself as well, because right now Thailand, many countries around the world, not only Thailand, but we put a lot of effort on placing UN Decade on Soil Health to the global agenda, and then we were discussing a lot on monitoring and assessment of the soil health at the larger scale. And do you have any idea or any recommendations on how we can monitor soil health using standardized methodologies or digital technology or any other like decision support tools to make it easy for us?
Yeah, we have converted decision support tools, and we have made it like a geographic information system, soil information system, GSIS. Okay. So the whole soil information system is available in the portal, in the geo portal of NBSS and LUP, National Bureau of Soil Survey and Land Use Planning in Nagpur. And so they repeatedly, gradually they keep on putting data as and when it is fetched. So this is always already there, already available. And so, and after my retirement, I am not sure, but now it was already there, but I retired in last February. So maybe possibly they are all their data available, because they are already always used for monitoring purpose. And we also share among our institutes, our regional, between institutes we share, because we develop a lot of things for climate change also. Say for climate change monitoring, mitigating, for mitigation and adaptation of climate change, we have to use the data, because otherwise we don't forecast, we can't forecast sort of data to the farmers, and immediately have farmers database through mobile. So we pass on the data to farmers through mobile. So these all things are available, apps with the help of some apps. So these are all available, and we have developed those monitoring systems also, particularly in view of the climate change, which is really a severe issue due to the high rainfall in the few number of days we have intensive rainfall, and the length of the rainfall has decreased, and the temperatures have risen. Even you can see people in France, they are sweating. In UK, they are sweating. So what about India? Also is a very terrible condition. I think it's a little better in your country. So that's what. So to monitor all those things, we have to monitor the climate change. And soil, is a repository of data, and it is having. I say it is a black box of nature, because from the soil you can say what changes have been done through the last so many years. I also have an experience in working in clays, in the clay mineralogies of soils. If I have opportunity, sometimes I can share. And from there, you can find that a lot of changes in mineralogy has happened due to the change in management of the various, human beings in various human epochs. Okay, so you can see the change in management in various geographical time duration. So it is very interesting to note that soil remembers, soil has a memory. Soil has a memory, and in my terms, I tell it is a black box of nature. And if you study it properly, not only soil health, the soil quality, which doesn't change for in the minimum of 40 to 50 years. If you can, 50 years is enough to change even the soil quality parameters. So we can study those changes and find out the changes in the climatic regimes. So we have a publication in P3, Paleo 3 is called Paleo 3. There we have shown how the changes in clay minerals have changed in the changes in climate change have changed in the minerals of the soils. That also is an important soil quality parameter. Thank you very much.
Thank you. Thank you. And we have Dr. Pawan raising a hand. Dr. Pawan.
Yes.
Please.
Thank you. Thank you, Pat.
Yeah.
Thank you, Pat. Very nice presentation. How are you? Today we are really good. I'm from India, and interacted with Professor earlier.
You're not audible properly, I think. Hello, I am not. It's not audible.
Hello.
Your voice is not clear.
Yeah, voice not clear.
Okay. Is it clear now?
Yeah.
Now it's clear.
Yes. Thank you, Dr. A. So I just wanted to update on this the soil health card scheme in India, which has done millions of soil tests using the grid system. So as per my information, the ministry at the central level has now converting all this data into an application which the farmers can use and see the data of their respective, not only the agroclimatic zone, but even further down where the soil testing has been done. whatever the results are, we not going into the quality of the results. But anyway, there's a huge database, millions and millions of records have been done, and there will be some kind of accuracy using the soil, the map also they have created. So all of that is getting converted into an application which will be farmer friendly and which can be used by the farmers themselves. So that is number one. Number two is my suggestion is that if you are still connected with your institute, maybe the data of the soil health, the physical and the biological properties of the soil, because they are changing. The biological properties particularly has changed particularly significantly over the last few years. So, is there? I don't know if that can be integrated into that app or not, but this data should be made available and it could be also solicited from the farmers because there are projects which are now running in the country. I recently came across a couple of projects which are targeting the soil carbon. So they say in the next 1 year, 2 years, if you are able to increase, double the soil carbon, so that is a good indicator of the soil health. So that kind of approaches are being done through the private sector as well as other agencies through the CSR approaches to double the soil carbon. And if you are able to double the soil carbon and bring a balance in the pH, maybe many of the soil indicators become balanced automatically. And but also at the same time, the soil microbial content has to, populations have to increase. And so very simple methodologies where I feel that unless we involve the farmer also in this entire process of getting him the ownership of his land and the soil monitoring, I think because otherwise it becomes very research oriented and the farmer doesn't benefit from this entire exercise. So that has been my experiences. I have done a couple of one large project on soil health monitoring covering an entire district, and we made soil maps, nutrient maps for of village wise maps, and then shared it with the farmers. So I think it creates an impact but doesn't create 100%. So soil health, I feel, has to be continuously dialogue with the farmer has to be there, and the dialogue at the lower level, at the grassroots level, the government functionaries, the various government functionaries and the village community has to come together to take control of their soil health and also look at the very simple indicators which could be used by them to monitor the soil health themselves also, and supplemented by the scientific evidence which is coming from various sources. And your institute, the institute has been a premier institute working for several decades now. Thank you so much, Dr. Ray.
Thank you. Yeah, you have said it all. It's needed. And they are doing, I think you also have done a quite bit of work. So that has to be taken ahead. We have to assimilate all sorts of these data sets, because this is a national level data sets, mainly for policymakers. So there are also many scientists and research workers in various state agriculture universities and ICAR institute. They're also doing locally. And those data sets, as you rightly said, can be also integrated into the apps which farmers use, and that can be supplied to farmers. And if we work more closely with the farmers, obviously we get better results. That's always. Thank you very much.
Thank you, Ka. Thank you very much. And I think the time is up now. So if anyone having any more questions, you can.
We have one question from the chat part.
Yeah.
From the chat box.
From Philippines.
Oh, right. All right. Sorry. Okay, this gonna be the last real questions. From the.
It may not be the last. I don't mind. I don't mind having 10 more questions. if it benefits students, particularly if it benefits students.
So the question from Elisha, if your research initiative currently utilize results from rapid soil analysis platforms or equipment such as Krishi Rasta for your national study in India?
I think if repeated was, please repeat. I couldn't get. Can you repeat, please? Let me this in the chat box. Hello. Can you hear me?
Yes, yes.
Can you please repeat it again? Yeah.
But request
Repeat the question, right?
because he
Sorry.
don't.
Yeah. Please
So
repeat the
sorry.
question again. Yeah.
My speaker is a little bit very low. So the question from Elisha, if your research initiative currently utilize results from rapid soil analysis platform or some equipment such as like Krishi Rasta, RASTAA for your national study in India?
No. What we have done is we have done most of it in a very religious manner in the laboratory methods using here. We have not used any sort of those so many apps and machines which have come. We have not used all those. Our laboratory data is very realistically drawn, and you can see even you can sometimes visit Nagpur Division of Soil Resource Studies. You can see my SRS, my email ID. So SRS is the Soil Resource Studies Division. So there we do all the work. We have not used any sort of those rapid analysis systems. We have used, of course, AAS, yeah, and we have used also other instruments, but we have not used any sort of automatic soil analytics systems which are being used for soil health parameters manywhere, and sometimes they are really faulty, because I am not satisfied with the type of with the repeatability of the data, and I always believe in data which is developed in the laboratory. If it is a wet method, so it should be developed with using the right methodologies. I don't say that they are not correct or they are not appropriate to be used, but some of the instruments like some MIDA something is there, so they are good enough. But each and every time we have to try to standardize it and monitor it also, because if it is thrown into a very interior region, there they may not have sufficient resources for running that, and so database may be hugely in disparity. So really we don't believe in rapid tests. Thank you.
Thank you. And thank you. We have the question, another question from the chat box, and also Kun Pawan as well. But I will go with the chat box first. From Zarina. Thank you for your presentations. And in terms of the relationship between soil quality, crop suitability, and agricultural mechanization, may I know if you have any existing system for suitability mapping that integrate soil quality and soil properties to recommend the most appropriate crop as well as most suitable agricultural machineries for a particular area?
No, we have. I have not done actually, but it is being done in our institute in Bhopal. They are trying to make it more mechanized one. So the database which we have developed, so that they put it into the system and into software, and they get the right choice for the crop. Yeah. So that I have not done actually. So I cannot tell anything about it. Thank you.
Thank you. Kun Pawan, are you going to have the last question?
Yes, Pat. Thanks.
Yes,
Thank you,
please.
Pat. Yeah, so Dr. Roy, I just want to know that I came across a document which said that they're going to promote spectroscopy-based soil testing methodologies as well. And they'd like to chemical-based testing because of various reasons. Cost is one, is another. So what is your take on that? This is something going to be part of the government's policy. And certain entrepreneurs who have done this using the spectroscopy, using the IIT Kanpur and other technological institutes methodologies. So what is your take on that way of soil testing?
We also do that. We also do a spectroscopy based one. So it's the future actually. In future, gradually we have to do away with the wet system analysis, and we have to go for these spectroscopy analysis. And but you should understand that one should understand that you cannot carry on doing it without monitoring or without standardizing regularly at regular intervals. I have seen many people, it depends on who is doing it. So I just, if you compare, say, Messi as a footballer and me as a footballer, so it will be a very bad precedence, So the quality of Messi is not the quality of me in football. So if people like me start playing football, so it will be very horrible for all of us. So I say that anybody using spectroscopy without having the proper knowledge and how to really interpret, he should have knowledge about the wet data also. How really we develop. I am a member of, Glasgow, FAO, okay? And the methodology they are developing is excellent. And we are developing, I get those data, I get those methodologies, and I am feel really proud of being a member of Glasgow. And because, but those have to be used sacrosanct. How can you assure that you can use the data in sacrosanct way? Even soil health cards have been done quite some time back, but can you assure that they are all correct? So that's my little, apprehension about how much you love your country and how well you can do it and how precisely or religiously you can do it. If you do it religiously, if you do it in a proper way and regularly testing the data in the laboratory, that would come with good results. But if it goes in the wrong hands, it goes to the other people, and then it will be total chaos, just like soil health cards. Thank you so much. Please don't take it otherwise, but I am very straightforward in this way. And I am really try to do work in the proper perspective. So I have had my experience in all this, burnt my fingers in soil health cards, and don't want to burn in these also. But if you do it in right perspective, it's certainly a very good technology. We should always go for reflectance studies and spectroscopic studies. We should always go for and decreasing the cost of so much of analysis to be done. But it has to be done with proper training, proper methodology, and with having love for their own country. Thank you.
ขอบคุณค่ะ คุณนพมณี do you have anything to say before I say goodbye to everyone? Because I assume that one was the last question for today. I
don't mind. Really, I'm enjoying it. It's a great opportunity which Nupuni Madam has given me. So let me enjoy it.
Thank you.
And we would happy to bring you back again one more time next time if we have chance to catch you up.
Thank you.
พี่นกมีอะไรอีกไหมคะ
ไม่มีละมันเลยเยอะละ
Okay, before we saying goodbye, I would like to thanks again to Dr. Sanjay Kumar Ray for your informative presentations, and I'm pretty sure your information can be a very good source for us to doing some more work and be one of our example to see. So, and thank you everyone for joining.
Can I say something?
Yes, sure, please.
I just wanted to know, because I made it very simple actually. So if people are doing very hardcore research, for them, the presentation would have been different. And so if this presentation should have been above par, or below par. So that assessment I don't know. I don't have, because I don't have the type of work you are. I know you are doing good work there, but if you want to elevate the standard also, the quality, without focusing more on the basics. So I wanted to focus on the basics, because I thought my viewers are more of students and young researchers. So based on that, so I take this opportunity to thank all of you, particularly Madam Nupene, all CESRA team, even Dr. Pavan also. Thank you so much for really encouraging me, and all the people here. Thank you very much.
Thank you. Thank you. And thank you for your nice word. And thank you everyone for joining us today. And before we saying goodbye again, we will please announce that the detail for the next CESRA talk will be shared to everyone via emails, and we looking forward to welcome you all again to our next sessions. And thank you everyone. Hope you have a great day. ขอบคุณค่ะ ขอบคุณค่ะ thank you ค่ะ
Thank you ค่ะ
ขอบคุณมากครับ thank you
Yeah, good.
yes I'm from Indonesia
Yeah.
That's great.
thank you Dr. Sanjay
Thank you all so much.
Thank you.